So welcome everybody. Thanks for coming here at this time of the day when the lunch is really heavy on your head and you're just waiting for the next coffee break. Thanks for coming. My name is Stefan Hammond. I'm working for this company that's involved in creating retail software, and inside that company I'm happily developing lots of DSLs and tools, just in-house tools for other developers inside the country. That's not the topic of today's talk. I'm happy and proud to be committer on, what's it called, the JDT. So you may have heard about my contributions to null annotations and null pointer analysis. That's also not the topic of the talk, but today I will be speaking about a project with this logo, Object Teams. And that's actually the reason why I joined the Eclipse community, because at university we developed a very brand new approach to software development, and this has become an Eclipse project, and that got me involved in hacking on the JDT compiler, and that got me involved as a committer here. We'll be speaking about dynamism. The title is a little bit of a lie. Java will stay as static as it is, but Object Teams built on top of Java as an extension of that will show some dynamism that you have not seen in Java so far. When speaking about dynamism, I would like to characterize the world of software development as being split into two camps. And I've grown up in this camp, or better, a city. So in that camp, we have strict rules, because we know that it's cool if a compiler can detect lots and lots of errors, not just type errors, null pointer errors, resource leaks, and whatnot. And we know that modularity is a key factor for maintainability, and we know that if we have boundaries in our software, that this helps us to figure out if something goes wrong, where it went wrong. That's a topic of blame assignment, and maybe we can even prevent some bad things from happening. And so that's where I grew up, and there's a lot of values in this society that I like very much. But every now and then I meet somebody who speaks completely different languages. So I speak static languages, and there's people who speak dynamic languages. And they live in completely different camps, and the language between these two words is mostly incompatible. And so they don't like a lot of ceremony. They don't like saying public static void. They only say the things that are really relevant to doing that job. They don't like rules and boundaries. They just want to do what they need to do, and they enjoy the freedom and the flexibility of the languages. And in the extreme, they can even write code that modifies itself, and that could even modify the semantics of the language that it's written in. And I had a little visit in that camp too, and I was using Lua for some development. I really was fascinated by the flexibility, but then I decided, well, for anything that should be maintainable, I live in a city where I know how the rules are and where I can check a lot of things. So why do I think that all these boundaries and rules are good? So the most prominent boundary, of course, is the boundary of an inside and an outside of some building block, module, component, whatever you name it. So with adhering to the rules connected to these boundaries, I get the ability to pick building blocks from the shelf, and all these shiny boxes that I can combine into my application, and most of this code in my application is already there. I don't have to code it myself. That's what we call reuse. The fine print on these boxes says, well, the one thing you do not get, you're not allowed to open a box and make any changes inside that box. You get the box as it is, and then you integrate it in your application. That's the rules you're abiding to. And it works great. You can build great applications in very little time until you hit what I seem to hit fairly often, what I call a near miss. So I find a component that looks great. It does mostly what I want to do. And it's a very good match, just not a perfect match. And then I need a hammer to get the square peg into the round hole, and lots of things. Doesn't really work. So what options do I have if I face a near miss? I could either say, well, if the component does behavior A, then I should just let my application show behavior A, and if the customer wants B, he just won't get it because I cannot do it with this component. So adjust the requirements to the building blocks I have in my application, but that's not very competitive because I'm just not fulfilling the requirements, and customer will probably look for a new software vendor. Or I can drop the existing building block and build it on my own, and then it will be a perfect match, not just a near miss. But that can be very expensive, depending on how large that building block was that you intended to reuse, and just cannot, because it is something is not quite right the way you need it. So why do I have that problem? I mean, we all know if you take a building block, it's just technically impossible to make changes so that in this application it will behave differently than in other applications. It's just no. And software engineering, technical impossibility is seldomly a good excuse for anything. So we should remember that if we have a black box component and it doesn't fit and we cannot make it fit, this is just a consequence of the rules that we decided to apply in software development. So if we decide the rules, that makes me kind of remember, well, there's people that don't even have these rules, and kind of makes me envious of how they live, and they don't even understand the problem in the first place, because in that world of the dynamic languages, they can make unlimited changes to any module that they fetch from wherever they get it from. And more precisely speaking, they have the possibility to make unanticipated adaptations to what they get. And these two words is something that the city world has a lot of problems with, unanticipated adaptations. So what could be the simplest possible illustration of the situation of unanticipated adaptation? I have one of these shiny boxes, implements a stopwatch. Can start, stop, and clear, and it ticks, so advancing the time while it's running. And now my job is to create a UI for that stopwatch. Well, that's easy. I create a new class, watch display, connected to the stopwatch. And then for the buttons on the display, it's easy to just invoke the functionality on the right-hand side thing. But then there comes a point where I need to connect the tick to the update. So left to right is easy, but how do I let the stopwatch trigger my update behavior? Well, we all know there is a pattern for this, and we have a solution for everything. The pattern is called listener infrastructure, but there is no listener infrastructure. This black box just doesn't have a listener. There's no register listener. There's no I'm notifying my listeners when I'm doing a tick. It's just not there. So it would be technically an easy thing, but just this adaptation has not been planned for to register listeners with the stopwatch, and so in the static world, I just cannot do this. This is a dead end. I cannot fulfill the requirement to display this efficiently in a UI. So at this point, I should probably think of, well, software is not the greatest business. Maybe I should grow potatoes and not use Eclipse or tools like that, but maybe that's a better tool to use. Or I need some additional smart. So thinking about what is it that we're really lacking here, we would need a concept that I would call method call interception. So whenever somebody sends a message tick to the stopwatch, I want to intercept this event and additionally invoke the update method on the display. And in fact, there is some infrastructure which supplies exactly this, which lets you install some interceptors, etc., for some components. But I'm a language guy. I don't really trust all those infrastructure solutions very much, and this would just be one example where it might accidentally work. I want a solution in my programming language, because then the tools can completely analyze what's going on. And so this is where we start to have a look at what we do in object teams. And the first step we're adding to Java is just one more compartment to this class here, still empty. And what I want to declare there, simply that I want to call update always after tick has been invoked. I have a connection to that stopwatch, and so I know which tick method that should be. It's exactly this one. And I just want to declare that everything after this has executed. I also want to update my display. And this is a language feature. And this is what is a visualization of this, like putting a little hook into this method so that it does some additional thing. It has a name in Object Teams. We call it call-in method binding, because looking from the left-hand entity, we're advising the right-hand side to call into myself and call this update method additionally. Has the flavors of before, after, and replace with the obvious meanings. And at this point, time for the first demo to see how it really works. So this is the 101 demo of Object Teams, and when you install the Object Teams development tooling, it actually ships a number of those simple examples, and all you need to do is click OK in this wizard, and you have this example in your workspace. And it has exactly this stopwatch class that I had on the slide, except that tick is now called advanced. Sorry for the inconsistency. But the point is, this class has no relation whatsoever to any UI. It doesn't have a listener infrastructure, nothing. And the watch UI is actually provided in two different variants. Let's look at the more fancy one. It has a constructor that creates a lot of widgets, which is not very interesting. It has action listeners on the buttons that invoke start, stop, and clear. This is the easy part, so let's skip over that big constructor. The interesting part, you already see in the outline, there's some funny declarations here, and the one we saw on the slide is this one. So translate advanced for tick. It's exactly the declaration. Update should always be invoked after advance has been invoked, and that also holds for reset. And executing this is integrated just as if I would be running a regular Java application. And so here you actually see two displays of the same stopwatch to demonstrate that it is just one model and two displays. Starting one, and both of them start ticking, and stopping the other one, both of them start. So it's just one stopwatch, and everything as plain and straightforward as it could be. So this works. Maybe we want to see a little bit under the hood how really this works. So let's look at this advanced method. Very simple, just increments the time. By the way, the IDE has a little marker telling me that the call-in binding applies to this, and I can use a context menu to navigate to that place that is intercepting this. But let's just restart the application in debug mode. And so first nothing happens, but as soon as I start the watch, the debugger kicks in. And I don't need console here. So first of all, I'm executing this method itself. At this point, you already see there's some dispatch code that has not been visible in source code, which you see in the stack trace here. But because this is irrelevant for the user, we grayed it out. So you see, OK, something's happening, but I don't have to care about this. Next step is the interesting part. Debugger actually jumps at this declarative point in the program where the method call interception happens. Next, we need to figure out the instance of watch display that is involved in this. I could tell more details, but it's not subject of this talk. And then I actually go into this update method. And the stack trace, I see, OK, this frame is a special frame because that's due to a declarative method binding. So it's green. We should pay attention to that one. We can step into that implementation. Wait a minute. So here's an invocation of getValue. There's one more interesting part about this. The watch display doesn't really have a method getValue. It has an abstract method getValue, actually. But there is another kind of method binding where I say I'm connecting the get method value that I want to invoke here to the existing get value method of the original stopwatch. So this is the opposite of a call-in binding. Now I'm calling it call-out. It's simple forwarding, and the debugger will show what happens here. I'm actually now navigating to the stopwatch underlying, etc. When that returns, I'm back in the update method of the UI. etc., etc. Let's just continue and see them running once more. So the tiny little addition that I made is just pretending I had a listener infrastructure, but I didn't even need to register. Just a little bit of method call interception solved this problem completely. Let me just clean it up. I don't need this example anymore. And go back to slides. So we can do this. And a few words about terminology are in place now. You may have seen funny identifier played by in the sources. It was located right where typically you would write extends or implements. Why am I using a completely different word, and why is such a weird word like played by? The terminology behind this. So far I only showed the mechanics of it, but there is a very strong metaphor behind this, and that's going to be explained on the next slide. The metaphor is called roles, and the corresponding thing is a base. Roles are connected to base things. What's the story behind these roles? We are actually correcting one of the most typical mistakes in textbooks on object-oriented programming. How many slide decks have this example? Employee is a subclass of person. Well, have you been born as an employee? So when I lose my job, retirement or otherwise, that would mean the instance employee has to be deleted from the system. That means the person is gone too. I hope I will survive retirement, so I need to fix this. And this is why I changed that extends into a played by thing, and I call this employee as a role, which is played by a person base. So now the played by makes sense. Employee is a role played by a person. The classes don't really show the interesting thing. The interesting things are only visible if you look at the instances. And this is Joe. Joe is an instance of person. Nothing more. Just has a name, nothing. But at some point during the life of Joe, he enrolls at a university. And he gets a matriculation number in his property, in his role as a student. Joe, the person, doesn't have a matriculation number, but Joe, the student, has. And the good thing is, even while he's still a student, he can also get a job and be an employee and a student at the same time. Salary is not so great at the time, but he's still a student. So what we get here is, leaves university still, but has this job. With this notion of roles, we get exactly one dimension of dynamism that we do not have if we just use static inheritance based only on classes. Roles can come and go during the lifetime of an object. You create it with minimal capabilities, you add roles and has more capabilities later on. And you can even be two employees at the same time. Second salary is a little bit better, so he may at some point just drop the first one because it was irrelevant. So you even get flexibility in terms of multiplicities. You can have the same properties multiple times. And all this is just taking the metaphor of a role literally as it is one of the fundamental notions of how humans think about social interactions and their participation in community. And in terms of programming language, it's actually only 3 new things we need, and you saw them all in this little stopwatch example, in order to implement roles in an extension of Java. We have this declaration played by, which, as I said, has the same location as extends and implements and can actually be used in addition to. So I can extend from one class and play a base of another class. And the one thing that started all this off is the method called interception, which we declare with a right to left arrow, call in method bindings. And then we have these funny left to right call out bindings, which would almost be completely trivial, with the exception of one property they add. A role and its base are actually kind of slices of the same conceptual thing. So the employee and the person is really the same thing. And for that reason, forwarding a method call from one slice to the other slice should not have to pay attention to visibility modifiers. What that means, these call-out method bindings can completely disregard visibility modifiers. And of course, that is a point where the moralists from both camps start fighting again. Because if I say I can invoke a private method from a role, which is not really inside, but kind of inside, then the moralists will say breaking those boundaries is just bad. And then the people from the dynamic camp will say, well, the boundaries are the things that's bad. And they will never come to a conclusion. So let's try to be pragmatic. There's truth on both sides. And what we're trying to do is just to realize that if we give more power to developers, with power comes responsibility. And so what we're trying with this language is to give to developers all the means that they need to, responsibly use this power in terms of that they can control the roles in a modular way and in a way that is easily analyzable, so that tools like compiler can still make strong guarantees about the program that results from all this. And so the next story will introduce one more kind of classes. If you only have roles, you're easily getting into a dilemma, because if a person has a phone number and you ask the person for the phone number, and if the employee role of that person has another phone number, it may be prudent to actually answer the office phone number, because maybe that's where I'm sitting right now, and if somebody calls me back at my home phone, it doesn't help a lot. But it may be a pretty bad idea to actually give my office phone number if I'm really just acting as a private person. So should this method call interception apply, or should it not apply? Can we answer that? No, we cannot. We are lacking context. And that's actually, if you say the word role, you immediately have to say roles in a context. And the context of a role like employee is obviously that I'm an employee inside a company. And so we model these contexts as another kind of classes, and this is what we call a team. Now you know why we call it object teams. Long story to get to the name. And then the main point in controlling roles is that each team has a switch where we can turn it on and off. So a context can become active or deactive. And with this, we're controlling all the method call interception. So when this call is received here, we're first looking, do we have a team associated with, that has any roles for this base class, base instance actually, and only if that team is active, then method call interception will happen. Otherwise, the system will be in its original state. So by grouping lots of roles into a team, there's one big switch that puts the system in one mode or another. And as we use team activation as the means of controlling all this, there's a lot of different options that we put into the language. First of all, you can deploy a team as something that is really part of the application right from the start. So it should be globally instantiated and activated. So this is really creating a variant of the original software versus something that's only temporal. So for example, you may want to have activation that's only applies for a certain block of code, or only for one thread, or for all threads, and you can control it programmatically or declaratively in your application description. That's the main point here. And I have a second demo where I can show off some of the things you can do with a team. And so this is already installed in this workspace, and the first thing I can show here is we have a third-party application. Let's call it the simplest, most possible mock application for booking flights with an airline. And the mock interface just allows me to register a new passenger, who is Joe the millionaire, who, I don't know. And so then I can select the passenger and book a flight, and all it does, it doesn't even print a ticket, only shows me to what degree the budget of this person has now been decreased. So this is not an exciting application. We're now adding a new feature to this application without modifying a single line of code of that application. We want to add to this application the feature of earning bonus points. And this is implemented as a team flight bonus. I'm not going to show much of the source. It is shipped with a tool, so you can explore it on your own if you install this. Main message is here to show that in many cases a team is actually a collaboration of several roles. So earning bonus points while booking flights involves the item that you're buying and also the subscriber who is the active part in buying. And one of them is bound to the base class passenger, and the other one is bound to the base class segment, as in a segment of a flight or a leg of a flight. And finally, there is another team that just hooks into the UI, and the main point here is that I declare each time after I'm adding a passenger to my passenger database, after that happens, I want to put up a new dialog to query whether that person should register for flight bonus program. And inside that method, I will then programmatically instantiate a new flight bonus team. And so this later part shows how the program can control some of its additional behavior by creating and activating this thing. And the other part I need to show is that in the run configuration of this application, I will simply add only the GUI connector and say this should be instantiated, activated immediately when we launch the application. And here it is, looks exactly as before, adding a new passenger, Joe the millionaire, and it asks me, register for flight bonus. This is the GUI connector kicking in, and now it has created a flight bonus team for this passenger. So if this passenger now books a flight, and only for him, the first dialog is, oh, you earned so many bonus points, 1,000 for the first leg and 7,000 for the second leg of the flight. And only after click OK, then I will see the results regarding the balance. And I've modified the application by just one bootstrapping and one subsequent team activation. One thing I still don't like, but before I show that, I would just activate one more team that is the man behind the curtain, by which I can show some dynamism. I'm running the application still in the same state, and now I show something which is a near miss. That's a near miss. Why is the dialog popping up in the upper left corner of the screen? I'm working in the center of the screen. This is not good usability. I want this dialog to appear right in the center of its parent. Okay, let's do some coding. Application is still running. And let's start by creating a new team class. Call it placer. Inside that team class, I will simply create a role class, call it centering. And the base class of this should be the class window from AWT. So I'm creating a role for window, and inside this, I only want to make one call in method binding to the pack method. Well, my own method I want to call center, and the kind of binding should be a call in after. Well, I don't have a center method, so I need a quick fix to create that method, and in implementing that method, I will simply say set location relative to get parent. Wait a minute. Content Assist offered me to use these methods, but these methods are not here. They are there, not here. They are existing in class window. So there's another quick fix which lets me materialize what the compiler was inferring, what I probably meant, which are these call out bindings, which simply do the forwarding part of it. Okay, I'm done. And I need to hurry as well. So application is still running. Dialog still pops up in the upper left corner. Too bad. This button just looks into the bin folder if there's any new classes. Oh, found one. What does it do? Puts the dialog right where I want it. So what happened? It actually, upon finding a new class, looks if that is a class that's compatible to the predefined org object teams I team. And if it does, instantiate and invoke its activate method, and the behavior will be visible immediately in the running application without any further ado. So, and I can even use the previous means of just deactivating the team at runtime, and then I have the old behavior. I can go back and forth, and now I have the new behavior, etc., etc. So there is this two-level dynamism. Once I have a team in my application, I can dynamically activate, deactivate it. But if I do not even have it when the application was launched, I can still add more teams while the application is already running, and I don't need any debug mode for that. But this is actually happening in could be happening in production code. Summing up, so you're probably wondering a little bit about the mechanics behind this. The typical thing to do for this kind of approach is to do some bytecode weaving, which we typically do at load time. If you really want to be sure what bytes are executed in the VM, you can actually do it before load time, you can do it at build time, which is not so exciting, but starting with an upcoming release, we will be able to actually show this runtime adaptation, even unanticipated runtime adaptation. Other than that, other than having this bytecode weaver, it's a completely normal Java application. It runs on any JVM, standard JVM, and there's two different integrations for standalone applications. You just have to add a Java agent to your command line, and if you're in some kind of Equinox setting, it's even just a standard OSGI weaving hook that we're leveraging, and that brings in all the possibility to do the bytecode weaving. And so this really is my summary slide, just going through all the phases that typically exist in software development, or there may be more or less, but basically something like this. Some people are developing building blocks, and maybe they are very, very smart, and maybe they already have the perfect, complete variability model of what different variants this building block should exhibit in any situations. If you're in this category, then all you need is extension points, and you're fine. But you probably have some crystal ball, because otherwise I don't know how you would come up with a complete variability model of any building block due to the concept of near miss and unanticipated. So if you're composing an application from existing things, you're just picking the boxes, writing your own code, and wiring everything, and everything is fine. And if in this phase you encounter something that's not quite right, then you need to play unanticipated adaptation. And for this, you need something like object teams for Java. And actually, this variant has been first demoed something like 10 years ago. So believe me that the language and the tooling has matured over quite some time, and there's a lot of material to read about. If you do deployment, it's basically the same. You do more wiring, more configuration. You could even, at that point, still do some more unanticipated adaptation. Just didn't fit on the slide. But the interesting part is that now, even while during operation of your application, you can still do some runtime adaptation, and that is the news in object teams in Neon. So I started out with complaining about boundaries restricting me. And this slide should actually show that the boundaries, even between development phases, can be ignored if you really need to. You can be in development mode all the way from development proper until operation. You can still continue developing your program, your application, while it is already running. And so, as I said, there's a lot more to read. Start from here, go into the wiki, and there's patterns and examples. And that concludes my talk. And please click on the left button. And thanks for your attention. I think we have some time for questions.
this compares to things like aspect J?
So the question is how it compares to things like aspect J. And the easy answer is originating from the same sources. So this has been developed in academic community of aspect-oriented software development. The good thing is that we started only after we already saw some of the problems with aspect J. So this can be considered, if you like, the aspect-oriented approach, it can be considered a second-generation aspect-oriented approach. And in particular, one problem which they have with maintainability is with point cuts that capture lots of execution points in your program, and these point cuts are reported to be very hard to maintain. We don't have it. We only have explicit bindings between explicitly listed pairs of methods. So that's one reason, and all this activation stuff, it's even much more dynamic than aspect J is. This is a short answer. Of course, conceptually, I believe the notion of roles is actually much more helpful for creating designs in this approach than the more technical notion of an aspect. Next, yeah?
So you have an example where a person can be in the role of an employee 2 times,
yeah.
working for 2 companies. So what happens if I want to access, the salary information, of, him working at company A or working at company B, right? So this access is difficult.
That's pretty much the answer you're giving yourself already. So you need the context. And so there's different means in the language for navigating from a role, from a base object to a role, and you always need to specify the team. Otherwise, if you do not know the team, there's no way you can ever access any role. And so by selecting the team, you're automatically also selecting the role that you're interested in. And so this is the answer for explicit access to that. The answer would be different if we talk about this call-in method binding that could fire into all the active teams, but then you probably only activate one at a time. But so the basic thing is you can only play the same thing multiple times if it is in different contexts, and the context selects which version you're referring to. One more?
So how do you set the scope for choosing which team will be activated? I saw you mentioned threads or global or
code block. The first distinction is trivial. Each team has a method activate, and that method takes a parameter. And the parameter can either be a thread or can be a constant all threads. And there's an overload, although I don't like overloading, where you can omit the parameter, and then it means the current thread. So this is how you select whether it's all threads or just one thread. And then there is another block construct, which we call within, which is just another Java curly braces construct. So between opening brace and closing brace, this team will be active. And then we have the declarations as part of the application configuration, where we globally instantiate and activate outside the program. So that's basically, additionally, there's fine-tuning that you can add predicate that this team or this role should only be active if the following predicate is true. And so there's different means of fine-tuning, but the basic one is just activate with a parameter. One more?
So how do you control the creation and destruction of contexts? Is that something that is programmed by the roles, or is this more globally in context?
Okay, so the creation and destruction of context is explicit. If there's no company, I cannot create a role for a company. But the opposite question is more intricate, because in some situations, we want roles to be created on demand. I create a context, I have a base object, and I want that all base objects of that type play a role in that context. And in that case, if we have method call interception, this method call interception has the ability to on demand create role instances. So activating such a team has the semantics of virtually adding rows to all the instances of all bases, adding a row to all of them, but they're created like